This is an example of an exponential graph. Right, around about 1800, population of the planet we're on is around about 1 billion. So these are in billions. And over time, what's happening? It's an exponential rise. Right. Along here on the y-axis, we've got a number of people infected with the virus, for example. At the beginning, there's nobody, and then, as you can see, there's an exponential rise. Right. Going back to the population of the planet, I mean, obviously our planet is not infinitely big, so this is not going to rise exponentially forever and ever. Right. Sooner or later, it's going to start tailing off, right? Because there are obviously limited number of resources on our planet. And same with this one here, with the number of people infected, right? Sooner or later, it will tail off. Right. Here's another exponential graph. Here's the y-axis. This could represent population, number of people infected with the virus, could be anything. And that one is x, the x-axis. That could represent, for example, time. The general form of an exponential graph looks like this. A multiplied by b to the power of x. Now you've seen other types of graphs, equations that have got x squared in it. Those are quadratic graphs, they've got U shapes. This one here, it's got the x as an exponent, right, as a power. What we need to do now for this question, we need to find the values of a and b to complete the equation. I can't just leave it as a and b because these have numbers and the clues are here, these numbers over here. So it starts off as 0 along the corridor, 5 up the stairs. This one, 3 along the corridor, 40 up the stairs. So 0 is the x-axis, so the x value, and that's the y value. X value, y value. X, remember, x could be time, y could be population, for example. Right. Now, what I'm going to do is, I'm going to go for the easiest one, that one there. I'm going to substitute the values of x equals 0, y is equal to 5 in here. So y is equal to 5, so that's 5. A, I don't know what it is, but I'm going to find out soon. So when x is 0, y is 5. But you know from basic algebra, anything to the power of 0 is 1. Anything to the power of 0 is 1. We know b to the power of 0 is 1. So that whole thing there is equal to 1. And then 1 times a, where you don't need to put, in algebra, you know you don't have to put the 1 there. If you got, for example, 1a, you don't need to put the 1. So just leave it as a then. B to the power of 0 is just 1, but you don't need to write the 1. You can just leave it as a. That's 5 is equal to a. A is equal to 5. So we found one of the letters already. We need to find the other letter. So far, y is equal to, do we know the value of a? Yes, we do. We just found it. Times b to the power of x. So how are we going to work out the other value of b? Well, the clue is here. When x is 3, y is 40. So 40 here, 5 times to the power of 3. We need to find b. To get rid of 5 times by 5, we need to divide by 5. What have you done this side? Do on this side as well. 5 knocks out 5. You're left with 40 divided by 5 is 8. Something to the power of 3 is equal to 8. Now to get rid of cubing, opposite of cubing is cube root. What have you done this side? Do it on the other side. Cube root of 8, you can do that on the calculator if you don't know, but cube root of 8 is actually 2. And then that cube root knocks out that cubing symbol, you're left with b. b is equal to 2. We now know our formula. The equation is y is equal to a is 5, look, times b we just worked out as 2 to the power of x. That there represents this exponential graph. I'll do one more, very similar one. All exponential equations have this form, but we need to find the value of a and b to get the equation. Start with the easiest one. When x is 0, y is equal to 2. So y is 2 when x is 0. You know b to the power of 0 is equal to 1. That's going to be 2 is equal to a times 1. But you don't really need the 1 there, do you? 1 times a is just a. We've found one of the letters already. Now we need to find the other letter, the value of the other letter, and this will help us. Y is equal to a, we know what it is now, times b, we don't know what b is, but we'll find out in a moment using this. When x is 2, y is 18. Y is 18, y is 18 there. And x is 2. To get rid of times by 2, divide by 2. Do the same on the other side. 18 divided by 2 is 9. 2 knocks out 2 like that. You're left with b squared. I think you can do this in your head. Something squared is equal to 9. B is equal to 3, because 3 squared is 9. Our equation is y is equal to, we know what the value of a is, it's 2 times, do we know what b is? We just worked it out there, to the power of x. Now I can use this equation to find any other points along this line. So if you ask me, for example, this is 1 on the corridor, something up the stairs, I can use this equation to work that, the y coordinate. Remember, that one there is the x coordinate and that's the y coordinate. So I'm just going to quickly show you then. When x is 1, what's the value y? What's the value y? When x is 1. 3 to the power of 1 is 3. 3 times 2 is 6. So we've got our answer there, 6. When it's 1 on the corridor, 6 up the stairs.